Hi everyone, welcome to Lecture 3 Part 2 on validity. The objectives for this video are the following. After watching, everyone should be able to: Number 1, define what it means for an argument to be logically valid. And number 2, determine whether an argument is valid or not using truth tables. So there's only 2 objectives for this video, and you'll have seen that the corresponding section in the book is relatively short. We've also already developed the skills we'll need to achieve the harder part of Objective 2, and that is constructing truth tables. The key takeaway for this part is the definition of validity. Now, I've dealt with this concept in the past before, and based on those experiences, this is a concept that we need to treat patiently so that we understand it well. Now, just before we get to the definition of validity, I want to stress that the term validity refers to a whole argument. So we have yet to look at arguments in proper detail, that's the subject of next week, but I'll give the definition of an argument as we'll understand the term in this course here, because we already know enough to be able to define it. So here's that definition. It says an argument is a list of statements, one of which is designated as the conclusion, and the rest of which are designated as premises. Now, we already know what a statement is. They were the subject of Lecture 2 Part 1. The way we'll write arguments, for the most part, is using abbreviations. So suppose we have 2 statements, P wedge Q and P. Suppose we designate P wedge Q as the premise and P as the conclusion. Then we write the argument that has P wedge Q as its premise and P as its conclusion, like this. So P wedge Q, then a line, and then P. The line always separates the premises from the conclusion, so everything on top of the line is a premise, and the thing underneath the line is the conclusion. And in this class, we'll only ever be dealing with one conclusion in arguments, so there'll only ever be one statement at the bottom in the arguments that we look at. Now, there might be more than one premise, though, and we'll see examples of arguments like that in a little while. In this case, though, there's just one premise, P wedge Q. So let's move on to the definition of validity. We say that an argument is valid just in case there are no cases in which all the premises are true and the conclusion is false. So let's look at an example of how this works. So we're interested in testing arguments for validity, and to do that we use truth tables. So let's take the previous example of the argument with P wedge Q as its premise and P as its conclusion, and test it for validity using the truth table. The steps are simple. So we start by constructing the truth table for all the premises. Now in this case there's only one premise, P wedge Q. So we go ahead and construct the truth table for that premise, for P wedge Q. Here I've started with its simple constituents, P and Q, so we can keep track of things. Now, of course, we probably know the truth table for P wedge Q by now, so that we could just write it down in one go, without having to record the tables for P and for Q separately. But when the premises get more complicated, which they will, it's a good idea to begin with the simple constituent statements so that you can keep track of everything. So I've done this here in the interest of good practice. So we know that this column for P wedge Q is true, false, 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 and that takes care of filling in the truth table for our premise. Now, once we've got the truth table for all the premises recorded, the next step is to go on and record the truth table for the conclusion too. Now in this case the conclusion is P, which we've in fact already recorded. So now we have everything we need to test the argument with P wedge Q as its premise and P as its conclusion for validity. So recall definition 2, which was the definition of validity. It said this: an argument is valid just in case there are no cases in which all the premises are true and the conclusion is false. So to test for validity, we simply check whether there are any cases in which all the premises are true and the conclusion is false. And if there aren't, then by the definition the argument is valid. And if there are, then the argument is invalid. So in our example here, we check first whether there are cases in which the premises are true. Now this happens in case 1 and case 1 only. So from now on, that's the only case that can possibly tell us whether the argument is valid or not. We no longer even care about the other rows in the truth table, so we restrict our attention to that first row. Now, the definition of validity tells us that we then need to check, in the case that we're interested in row 1 here, whether the conclusion is true or false there. So we check, and we see that in the case of interest, the conclusion is also true. So we conclude that there are no cases in which the premise of this argument is true and the conclusion is false. So this argument is valid. Now let's look at one more example. This time we'll use more than one premise. This is the one from the book. The argument is this. Here, not P and PVQ are its premises. We write them side by side on the line. Sometimes the premises are also written stacked one on top of the other. Those two ways of writing them, there's no difference between them. They mean the same thing for us. Now, we want to test this argument for validity, so we recall the steps. First, we construct the truth table for all of the premises, so let's do that. We start with a column for P and a column for Q, since they are the simple constituents involved in the premises. We record the possible truth values in the usual way. So in case 1, P is true and Q is true. In case 2, P is true and Q is false. In case 3, P is false and Q is true. And in case 4, both P and Q are false. Now, the first premise that we're interested in is not P. So we extend the table to include the truth table for that premise. And filling in the truth table is easy in this case because we know that not P is true just in case P is false. So in cases 1 and 2, P is true, so we know that not P is false in those cases. And in cases 3 and 4, P is false, so we know that not P is true in those cases. So we've recorded the truth table for the first premise. Now we go and do the same for the second premise, PVQ. This one's easy again. This is just the truth table for the V symbol. So in case 1, P is true and Q is true. So at least one disjunct is true. So we know that PVQ is true. In case 2, P is true and Q is false. So at least one disjunct is true. This one is P. So we know that PVQ is true. In case 3, P is false and Q is true. So again, at least one disjunct is true. It's Q this time. So PVQ is true. And in case 4, neither P nor Q is true, so neither disjunct is true, so PVQ is false. Now we've recorded the truth table for all the premises, we've got both of them in there. So the next job is to record the truth table for the conclusion. And the conclusion of our argument is Q, so we see in fact we've already got this truth table recorded. So that's the conclusion done. Final thing to do is to see whether there are any cases in which all the premises are true and the conclusion is false. This time there are two premises, so to check whether there are cases in which all the premises are true, we want to check if there are cases in which both not P and PVQ are true, because they are our premises. Now if we look at the table, we find that this is the case in row 3 only. So that's the only case we care about from now on. And the last thing we need to do is to check whether in that case of interest, in row 3, the conclusion is true or false. Now if we look at the table, we see that the conclusion is true in this case. So we conclude that there are no cases in which all the premises of this argument are true and the conclusion is false. And therefore this argument is valid. Now let's walk through one more example, this time with a few questions from me. So let's look at this argument. Its premises are P and PVQ, and its conclusion is Q. So here's question 1. What is the first thing we do to test this argument for validity? The first step is to record the truth table for all of the premises. So we start in the same way by recording the truth table for the simplest constituents, P and Q. Now P is one of the premises, so one of them is already taken care of. The other premise is PVQ, so we record the table for that alongside what we already have. So here's question 2. What is the completed truth table for the second premise, PVQ? We know the table for PVQ is this. It's true in cases 1, 2, and 3, and it's false in case 4. So we've recorded the truth table for all the premises. We've got them both in there. So question 3 is, what's the next step in testing this argument for validity? The next step is to record the truth table for the conclusion. Now in this case, the conclusion is Q, so if we look at the table, we see that in fact we've already recorded it. So here's question 4. What is the next step in testing this argument for validity? The next step is to check whether there are any cases in which all the premises are true and the conclusion is false. So here's question 5. Which are the cases in which all the premises are true? That's these cases, cases 1 and 2. There we see that both P and PVQ are both true, so they're the ones that we're interested in from now on. Here's question 6. What is the next step in testing this argument for validity? Next, we check whether in those cases of interest, cases 1 and 2, whether the conclusion is true or false there. And here, if we look at the table, we see that case 2 is a case in which all the premises are true, but the conclusion is false, and case 1 is not, because the conclusion is true there. So, we conclude that there are cases in which all the premises of this argument are true, and the conclusion is false. That's what happens in case 2. So, we conclude that this argument is invalid. Okay, good stuff. So there'll be lots more practicing of that, questions of that kind in the large group problems and in the discussion problems. And again, practice is the way to get good at those types of question. Now, this brings us to the end of the chapter 1 material. So next time we'll start on the chapter 2 material, looking at arguments and logic in more detail. So just before you finish, do your self-reflections, and I'll see you all next time.